Okay, so we're going to go through some very basic principles of movement. So we're diving into mobility and motor control and how we can manipulate these, these principles within our coaching and our clinical practice. So the outcomes that we're expected to pick up along the way is we're going to define mobility. We're going to define stability, we're going to define motor control, and we're going to define flexibility. But on top of all of that, we're also going to understand how we can manipulate these principles within a program. I'll start by saying that the definitions of mobility, stability, motor control, and flexibility they're typically quite loose within the industry. Everyone has an opinion on whether or not mobility is this or stability is this. All that I'm trying to do is create very simple principles based on the literal definitions of these things, so that if you want to branch off and specialize in mobility, then at least if you're having a conversation about mobility with somebody who's new to the industry, they should be able to understand what you're talking about by basing it back to the principles that we are going to discuss in here. So I'm not saying that these are the best things in the world and that I'm right, but I am saying that this is the best definition I've come across for mobility, stability, motor control, flexibility, and I will give you a bit of an insight into how I use them as tools, coaching and clinically. So let's dive in. So we've got the current model. The current model for mobility is how far you can move a joint under your own body's control without external influence. Now, this is something that I've seen several times in different courses throughout my education, and also a couple of different principles that have been adopted by coaches and clinicians that I know and that I speak to on a regular basis. And then stability is how well you can control the mobility that you have, and stability is also called motor control in these circles. Or it's simply stated is how well you control your motion or your movement. But I feel like this philosophy of mobility and stability and how they are almost two ends of a spectrum is a little bit outdated, because it doesn't really respect the principles of movement and also the different interpretations of movement as it resides on a continuum, which we're going to explore. So let's explore a little bit of why I have a different take on it. Again, I'm not saying that I'm right. I'm just trying to create a conversation where everyone can come to some sort of agreement. And I'm very open to suggestions. But if we can come to an agreement and base the decisions that we make as a coach or as a clinician, or even as an athlete, on whether or not we're going to adopt this mobility stimulus, or adopt this motor control corrective, or we're going to work on this aspect of flexibility, or we're going to be developing our stability through a joint based upon this exercise variation, then at least we're talking the same language, and it should be pretty easy to transfer a client from a coach to a clinician, or a program from a coach to a coach, or a clinician, etc. So while I don't believe that these are bad rules, I don't want to call them principles, because there's so much more to be explored. And I feel like we can get a little deeper before we can come back out to the shallow waters closer to shore. So we're going to do that right now. We're going to look at a different take to mobility. So if we're looking at a way to actually define mobility, mobility can be defined as the range of motion a joint needs in order to perform the function of that joint. And if we remember back to defining performance, function is task specific. It is not what something looks like that dictates function, but rather what something can/should be able to do. So if we take a look at the shoulder girdle and the glenohumeral joint in this example, functionally, so task specifically, the glenohumeral joint should be able to access a minimum of 170 degrees of clean flexion before we get any posterior tilting of the scapula or upward rotation, where we're getting into those last end ranges of shoulder flexion close to 180 degrees. 50 degrees of clean extension before we're getting that anterior tilting of the scapula. 90 degrees of clean external rotation. 60 degrees of clean internal rotation. We've also got abduction and adduction, but I've left them out on purpose because at least these four are very easy to measure in either a standing or a supine position. Extension, you could measure that in prone. But I've left the others out because stuff like abduction, even the rotations, are coupled with flexion and extension. So when I flex my shoulder, I'm actually getting an external rotation and an abduction moment happening at my shoulder joint. So it can feasibly be suggested that if you find a problem when you assess in flexion, that could carry over to your ability to access external rotation or abduction if one of those two is impeding your ability to flex a shoulder. And if you're working with an athlete or even a non-athlete who just likes to play a sport like baseball, who likes to throw, and they get pain when they throw, then finding these deviations away from the norm could be great ways to influence your treatment or your coaching and your correctives. So if the shoulder you assess cannot access these ranges, it would be deemed not functional based on what we were just talking about before. If we go all the way back, based on the fact that, or the definition of function being that function is task specific, and that we've just agreed, it cannot be disputed, that these are the minimum ranges that we should expect to see within a healthy shoulder. So if the shoulder that you've assessed can't access these ranges, it would be deemed not functional or not healthy or dysfunctional in relation to how a normal shoulder should function based on the anatomy of the shoulder girdle. So I'm not making any grandiose statements and saying, I think this. This is based on something that everybody within the medical world has agreed on that a shoulder should be able to do. Now, if I deem that shoulder cannot perform these functions or these tasks, I'm going to call it dysfunctional. However, so it is therefore the responsibility of the coach or the clinician to prove any noted deviations from normal are dysfunctional based on how that individual uses that specific joint within a pattern. Let's take it back a couple of minutes when I was saying we've got an athlete, maybe a non-athlete as well, but they play a sport where they like to throw. There's going to be some specific deviations away from normal because they may excessively use that joint as part of a pattern that they deem functional for the task or the hobby that they do or the sport they play. This example, a baseball pitcher, so a professional athlete, will have excessively more external rotation and as a result will have less internal rotation. This is called a shifted arc on their throwing arm. So the question you would have to ask yourself, and something that you can ponder, is this deviation dysfunctional for that individual? The obvious answer is no, it is not, because function is task specific. And for this individual, this athlete, the task is to throw a ball as hard and as fast as they can. So they need to access this range. The shifted arc is functional for this athlete, but if they wanted to go and perform as an Olympic lifter and they're trying to press the bar over their head in a jerk, then it may be deemed dysfunctional for the task of the jerk. So we've got to have the understanding or the scope. We've got to keep our scope in mind of what does the shoulder need to do? What am I trying to get the shoulder to do? And what is this individual trying to get the shoulder to do? Let's meet in the middle somewhere before we just start labeling things as dysfunctional and functional. Understanding what is right goes a long way in order to be able to deem what is wrong or dysfunctional. We're going to continue on this different take. So we're going to move on to stability. Stability can be defined simply as an opportunity to demonstrate one's ability to resist or navigate force in one or multiple planes. So if we take it back to the original definition where stability is an ability to control motion, or it can be called motor control, I tend to lean away from that definition, and I get a little more specific in that stability is an opportunity, it's a snapshot in time to demonstrate one's ability to resist or navigate force rather than to simply control motion. And we're going to get a little deeper between the difference of stability and motor control, but let's talk about the stability right now. This demonstration is typically done in a static, non-moving, or a dynamic, moving fashion. So let's look at an example of static stability. Static stability would be a joint that does not move in one plane or any plane while other parts of the body are moving. So an example of static stability could be me performing a weighter's carry with a dumbbell or a kettlebell in my hand. So I'm going to press that dumbbell or kettlebell into the overhead position, and then I'm going to walk. My shoulder is in end range flexion, and I'm expressing static stability at that joint. I am saying, joint, do not move in any plane. I instead want you to navigate and resist the forces that are occurring in the sagittal, the coronal, and the rotary plane of that shoulder while I walk. So now I have parts that are moving, which are my hip bones, and my trunk is having to remain stable so that my shoulder can stay stable. I'm trying to express static stability at my shoulder. And this is a great understanding to have for things like rehabilitation, or even if you wanted to develop capacity in a shoulder girdle, because when static stability runs out, the drill that you've imposed becomes very self-limiting. Someone will start to sag, and you will see that that person can no longer demonstrate their ability to resist or navigate the force. So now you have an objective means, and that person has a subjective means of changing the stimulus to maybe a different position. And if we were to take it from this position of overhead into a front rack, we're now expressing the same stimulus, static stability of the shoulder girdle, but we're simply changing the position of the shoulder. So we've gone from a flexed position to a more extended position. We've just taken the load, and we're still moving it a little further away from the spine. So we've still got a little bit of a perturbed stimulus happening at the spine, but it's less strenuous on the shoulder girdle because we've taken the shoulder out of its end range flexion. Now, an example of dynamic stability would be a joint that is moving in one plane while resisting the forces trying to move it into the other two planes. So if we were to look at, say, for example, a single leg deadlift, I'm going to take one leg off the floor and reach it back. The leg that I keep on the floor is moving into flexion, and I have to resist the forces of rotation and lateral movement through frontal plane in order to keep my moving leg, so the leg that trails behind me, and the trunk, I have to keep those in a straight line. So I've got to be able to navigate the forces of rotary and frontal plane while I manage that hip in flexion. Angus, just turn your mic on mute, my dog.
Oh, yeah, sorry, I just joined.
All G. So dynamic stability, a joint that is moving, so the hip joint in this single leg deadlift, while resisting the forces of external rotation and abduction. And you can tell when that doesn't occur because now they're, turning their body away from the leg that's on the floor. If they're running out of clean flexion, they may start abducting at the hip. And we'll see that as like kind of aeroplaning away. Or they may start external rotating where they're no longer in the sagittal plane. They're starting to rotate into a different plane like the needle on a compass. Understanding this principle becomes crucial to the next several slides, and we're going to discuss this in a little bit more depth. But as you will find, when coaches or clinicians set constraints for a client who is being taken through some corrective exercise or movement variation, all we are doing is enforcing a static or dynamic stimulus on them in order to produce a training or rehabilitation effect. So when you are coaching or cueing an individual, all you're trying to do is get a part to either move or not move more efficiently. You're just trying to constrain them with a static or dynamic stability. And when you start to pick apart movement patterns, it becomes very easy to coach these. We may have already discussed this, but you get more out of coaching non-moving parts than you do moving parts. And I know this is part of the next module, module 3, when we start talking about the pillar and moving and non-moving parts, but just understand that within a pattern, you will get more out of a coaching or cueing movement by coaching the parts that shouldn't be moving rather than trying to coach the parts that do. So let's go back to our dynamic stability example. If I'm coaching a single leg deadlift, I'm going to get more out of this cue by telling them, hey, I want you to maintain this front side facing either the wall in front of you or the floor below you. Don't let your chest roll away from this front side. And hey, that back leg, I don't want you trailing that leg out or turning the foot. So what I'm going to ask your nervous system to do is demonstrate, can you keep yourself in a straight line? If you can't, then I might get tactile and get my hands on and say, hey, can you see or feel that you're doing this? But all we're doing is we're just asking the nervous system to impose these self-limiting moments on itself where we're either statically or dynamically expressing stability. And that's how stability is broken out. So put simply, do you want this part/parts to move? If yes, you are challenging that part dynamically within a pattern. If we take it back, that joint that joint will be moving in one plane while it resists the forces in the other two planes. So if we're doing that single leg deadlift, we want the part to move in flexion. We don't want it to move into excessive abduction and external rotation. If we don't want the part to move, then we are challenging this part statically within a pattern. So we've got that overhead press position and we're walking. This is still a pattern because we're expressing movement. So we're walking, but we've got the shoulder girdle in end range flexion. We're asking it to not move in any plane. We're going to keep going down this different take. We're going to look at motor control. So motor control can be defined literally as your control of motion through a pattern. So now we're starting to get a little bit more specific between stability, which is, can you express movement or non-movement? And now we're asking, hey, how well do you control that movement? Is it clean and easy, or is it dirty and difficult? So the difference here between mobility and stability is that up until now, we haven't discussed the level of control you can demonstrate as you access your end range with a pattern. Very important word here is end range, because motor control isn't tested until you get into end range. You can watch someone move cleanly through a pattern, but if they move into their end range, that's where the pattern will be challenged the most. So stability, static stability, can be tested and can be, measured in end range, and that's an element of motor control. But moving from A to B dynamically, that won't be expressed as a level of control until you reach that end range. So my little problem with, encompassing the control of motion within the definition of mobility and stability is that it doesn't provide a very accurate representation of how well someone moves. And as I said before, clean and easy, dirty and difficult, these are words that I use, and I want to invite clients that I work with to feel this. I want them to say to me, that felt dirty and difficult, or that didn't feel too great, or hey, that felt really good, that felt really clean. Because when they can start to dial in on when it feels good and when it doesn't feel so good, now we're starting to build what I like to call feel. So this feel is motor control, essentially, right? What we're talking about is mind-muscle connection, or there's so many different sort of analogies for it, but mind-muscle or what's the other word? There's mind-muscle connection. There's another one that it'll come to me, and when it comes to me, I'll just blurt it out. But at the same time, we're just building motor control, right? And we're building feel. And I like to ask people to move into their end range, whether under load or not, and feel for when that joint runs out of range, because something else will start to move as a result. So if we look at hip flexion, for example, within a squat, if we are going to squat, we have to have an ankle that dorsiflexes, a tibiofemoral joint, which internally rotates, against a femur, which externally rotates, within a hip socket that flexes and abducts and externally rotates. If we run out of one of those ranges, then something else has to start moving, because that position has no longer kept moving, it's stopped. When you have great motor control, you will feel when you run out of range in one of those positions, and then you'll be able to dial in on why you've run out of range, and then you can start to take control of your own mobility and motor control. It could be any number of reasons that one of those parts stops moving within a pattern, but when it does, we've unequivocally got a position of compensation or a position of dysfunction. We don't own that position anymore because one of the parts has stopped moving, and it should be moving within this pattern. So having a level of feel that you can develop is very important when it comes to developing motor control, but you can't teach this in a client until you've learned it for yourself. Very important. So we'll talk about it right now. Knowing or feeling your way through a pattern into your end range can be game-changing. There are several neuromuscular principles that come into play here, but one in particular is called successive induction and involves consciously creating tension through an antagonist muscle. So if we've got my elbow flexing, then I've got bicep working as my agonist, and then opposing muscle would be the antagonist, the tricep. The principle of successive induction here is we are creating tension through the antagonist muscle while an agonist muscle moves through a joint's range. So I would be creating tension through my tricep. So I'm extending, I'm going to create tension, maintain that tension, and now I am creating elbow flexion against tricep tension. And you can see that I actually got a little bit more contraction through my bicep. So if I just contract my bicep, you know, yeah, it looks flashy. But if I want to get a little bit more contraction out of that bicep, I can start an extension of my elbow, get my tricep on, and now I'm creating tension in my tricep and I'm flexing my elbow against my tricep. And I am getting some serious contraction through my tricep as it eccentrically lengthens against my bicep, which is concentrically shortening against my tricep. So it creates a lot of tension throughout a joint. Now, this happens all the way through every muscle. We don't feel it though necessarily, but this is how muscles create movement. They have an agonist create tension against an antagonist, which creates reciprocal tension. This is another neuromuscular principle called reciprocal inhibition. But if we want to maximize on this, say we're lifting heavy, I've got a video here that we can watch, but let's look at the squat. So the glutes eccentrically lengthen as hip flexors concentrically shorten to create more tension within the glutes through the concentric phase of a squat. I'm going to load this video up. Now, this video is of a lifter called Steffi Cohen. She holds the, I think the 66 kilo world record for deadlift and squat. And I want you to watch how she squats, and then we're going to talk about it really quick. So let's load it up and see if it loads on the right screen. It sure didn't. Why would it? So let me screen share this screen. If it wants to load. All right, so we're going to screen share this bad boy. Okay, now can we see this YouTube video, this screen? Just thumbs up or thumbs down. Great, okay, so I'm going to fast forward to the squat. Let me turn this down a little. So we're watching how she squats. As she comes down through the eccentric phase of the squat, I want you to watch what she does to create tension at the hips. And she does this very differently to most people, how they squat. She pulls herself down into the hole rather than dropping. What she's doing is taking advantage of this principle, successive induction. She's using her hip flexors to pull her into hip flexion, and she's using her glutes to resist that. And she's creating a lot of joint tension at the hip joint. As a result, when she comes out of the hole, her glutes are now lengthened, but they are lengthened under tension. And this is a good thing for the glutes because the glutes have to help her hip extend. So now she's taking advantage of the principles of length and tension, but she's doing it via the neuromuscular principle of successive induction. Watch her as she drives out of the hole. The bar flies, right? So we've got so many things happening at the hip. Glutes are extending the hip. Quads are getting involved on the way up because they've generated a lot of tension on the way down. So now she's got glute and quad tension, and they're both working to express hip extension. This is successive induction. The opposite would be when you see someone drop into a hole and then they have to force their way out of the hole, and they've created no tension on the way down through their hips. So now they've dropped into the hole and they're taking advantage of a principle called stretch shorten reflex within a muscle, but they're doing it inappropriately because they've created no tension within the muscle. They've created no stretch. They're loading the muscle at the bottom of the movement, as opposed to what Steffi does here, where she loads the muscle at the top and then lengthens the muscle as it goes down. So it's a very cool principle, and it's something that I encourage you guys to practice yourself. You can practice this by laying on your back and having someone just lightly grab your foot and give you a little bit of resistance as you bring your hip into flexion and you bend your knee to simulate a squat pattern. And then feel your hip flexors as they resist this person resisting you moving into hip flexion. And as you do, see if you can get some glute control to stabilize the hip as you come up, because the hip flexors need something to pull against. It's very important. It's very important to understand. Now, as we get our one-on-ones, we can explore that a little bit more in depth, but just understand that this successive induction is something that's very misunderstood, and it happens all around us. And if you want to maximize strength or power or speed, understand this principle. If you want to improve somebody on the table, if you want to expedite somebody's rehabilitative process, then understand this principle.
I got a question, Cam.
Write it down for me, man, and we'll talk about it at the end, because I've got to record this bad boy, and then we can chuck it in at the end, baby. All right, let's move on. Particularly under load, this principle. So under load, this one really lights up. This principle helps to create more tension at a joint on both sides of the joint, which is what we saw with Steffi. Remember, even ball and socket joints aren't single-sided, single-plane joints, but when we look at them in an anatomy book, we say, oh yeah, the flexors flex, the extensors extend, the adductors adduct, and the abductors abduct. And we think about it in a very two-dimensional way, but the reality is the joint is a three-dimensional joint. And we're going to explore that right now. When they move through a range like flexion, so remember, we think flexion, we think this two-dimensional movement. Even a ball and the ball and socket joint moves in flexion, they're having to express dynamic stability against excessive AB or adduction and external or internal rotation. So we know that a hip, as it flexes, is coupled with external rotation and abduction. I'll repeat that. When a hip moves through flexion, it is coupled with abduction and external rotation. That's how the ball and socket joint moves through the joint. These ranges still occur, or these movements still occur, and that's what allows us to achieve depth when we squat. But we need to be able to navigate those movements on the way down, not just flexion, not just extension. When we're only thinking about the joint in a two-dimensional way, you'll see things like excessive valgus occurring at the knee, where the knees cave in, or you'll see people just simply lose tension at the bar, and they'll lose their spine, or they'll lose the bar off their back, or whatever it is, because they've lost all of the tension. Get this bloody thing off. They've lost all of the tension in their hip, because they're only thinking about the movement in a two-dimensional way. So we continue on. These muscles that help with moving through the range, abduction and external internal rotation, they're still working while the femur moves through flexion. And so these muscles need to have the flexibility, and we're going to talk about flexibility next, to get involved in the flexion pattern without getting in the way. This is an important thing to remember. So if you're going to write any notes, write this down. The flexibility to get involved in a pattern without getting in the way of the pattern. So let's have a little bit of a deep dive. We're going to go into flexibility. So flexibility, this is a bit of a bastardized word that gets thrown around a lot. Flexibility can be defined as the length or contractility of a muscle or connective tissue as it pertains to a joint, or a joint's active and passive mobility. So remember, mobility is the range a joint needs. Flexibility is how much length is there actively and passively, or contractility, so that that joint can express its range. Muscles have been shoehorned into categories like short, tight, and lengthened weak for a very long time within both the coaching and clinical worlds. When we treat muscles with this isolationist mentality, tissues like pec minor, a commonly tight tissue, gets abused by therapists with their hands and tools, or coaches with their tools, and is commonly blamed for chronic shoulder pain or poor performance throughout the shoulder girdle. As a result of this mindset, muscles like the antagonist rhomboid group are usually encouraged, especially in coaching, to be overly trained, again in isolation, without any thought for how the shoulder girdle as a whole functions, including the humerus and lower portion of that limb. We're going to deep dive on that next week when we talk about moving and non-moving parts, but just understand that muscles and parts in general don't work in isolation. And I've just proven that when we talked about things like successive induction. They have this beautiful relationship that works like a dance with agonist and antagonist muscles, but it doesn't happen in 2 dimensions. It happens in 3 dimensions all the time at once. This does not help to improve the contractility of the pec minor. So when we talk about just smashing the pec minor and then stretching out the pec minor and then, strengthening the antagonist rhomboids, this does not help to improve the contractility of that pec minor. That tissue has not been reintegrated into a pattern. It is still chronically short and tight. And so no improvements to mobility or motor control can be made by simply isolating another muscle group and trying to build volume within it. That's not how the body works. You will still make a change and get gains out of that, but that's not the most efficient or effective way to do it. So this is the reason why I encourage a patterns approach rather than a parts approach with my coaching and clinical rehab work. Consider, if you want to get the most out of a part, then understand the role that part plays in the following pattern paradigm. Now, this is one I got from Greg Day. In order to challenge a part, your constraints should involve multiple joints within a limb compared to an isolated joint. Your constraints should involve multiple limbs compared to a single limb, involve multiple limbs between upper and lower body, involve multiple limbs on opposite sides of the body, involve movement across the midline, involve multiple postures from the ground up. All of these we get to explore in the next module, but just understand that in order to adopt this patterns over parts approach, we need to understand that no part ever works in isolation, ever. I challenge you to find a part that works in isolation. Improving a shoulder pain that you yourself have either assessed or had assessed that implicates the pec minor as a contributing factor to aggravating those symptoms can be addressed by involving the joints that get involved in patterns from the spine down to a peripheral point like the hand, as the pec minor and its antagonist is utilized across a spectrum of its length and functional requirements instead of isolated in bastardized or chopped patterns. I'm going to break out that whole paragraph right now. All I'm saying is, if you want to get more out of that shoulder pain, then get it assessed, then get it treated, find a way that you can take away the symptoms. So manage the symptoms, then reintegrate that whole shoulder into a pattern that you can progressively overload that doesn't exacerbate your symptoms, and your pain will go away. What it won't do is it won't go away if all you do is just face pulls because you're trying to strengthen your rhomboids or stretching your pec minor. So here's an example of a shoulder program for pain with pec minor being implicated upon assessment and advisement from the clinician that trigger point therapy was effective at minimizing pec minor tone and pain at rest and through passive active ROMs. So let's keep flexibility in mind here. So we've got our SMR or trigger point element and corrective work. So one, we've got our lacrosse ball into pec minor for 2 minutes, door frame stretch for 2 minutes, and banded face pulls 12 to 15 reps. This is, by the way, this is a program I've actually got access to that was prescribed by an exercise physiologist. Not to say exercise physiologists are wrong here. I'm just saying that this is how the current model works. Then we move into a main lift. Heavy goblet squat to box 3x6, incline dumbbell row 3x10, prone hand cut 3x10. And then we've got our accessory lift section. So we've got a dumbbell flat bench press 3x5, dumbbell front foot elevated split squat 3x8 to 12 per side, and then single arm cable row 3x10 per side. This isn't a bad program at all. Based on what we learned last week about exposure and adaptation, we will make gains from this program. We absolutely will. But the pec needs to do work in order to improve the quality of tissue within it, the quality of that contractility, the tone. So this will go a long way to improving flexibility and all around tone of the tissue, but it won't allow it to reintegrate itself into the pattern because we've got stuff in here like a face pull, which is just focusing on the rhomboids in isolation. Then we move on to incline dumbbell row. And a lot of people coach an incline dumbbell row as scaps set and retraction. I like to coach with a reach. But if we're just going scaps retracted, then we're not getting any pec minor involvement. Pec minor is just being shortened and stabilizing. Prone handcuff, not a bad one, but 3x10. If you've never done a prone handcuff, I challenge you to do 10 reps of it after you've done 10 rows. And then we move on to the flat bench. So again, dumbbell flat bench, you pin your scaps in retraction and downward rotation. Again, pec minor just gets shortened and it becomes a stabilizer. So we're not improving the contractility of this muscle. Dumbbell front foot elevated split squat, whatever. I mean, we're just working off the heavy goblet squat. And then single arm cable row. Again, a lot of people coach a row as retraction through the rhomboid, the scap. And I like to coach a reach. So we can move through into a different take, which is a program that I wrote based on this exercise physiologist program that they sent me around shoulder pain. And I said, why don't we consider the following? And I'm going to go through these videos off the recording so that we can go through them together in the next 15 minutes. But I'm just going to get through this recording. So self-myofascial release and trigger point. Let's get the lacrosse ball into the pec minor. We don't have to spend 2 minutes there, just until we feel a little change. And then we can do a couple of correctives that I've got links to. But they're both with a reach, a shoulder blade reach, because we want to get that pec minor working through some protraction, working through some upward rotation, because it gets involved in these patterns. It even gets involved in downward rotation. It's part of the whole thing. Main lift section, I said, hey, let's keep the heavy goblet box squats. I don't hate it. I think it's a great way to express static stability at the shoulder while we express dynamic stability at the hips. Let's do our 3x6, but let's do a behind the neck dowel press so that we can get a little bit of shoulder and like shoulder girdle movement happening. We can get a little reach at the top and a bit of downward rotation at the bottom. So we're getting pec minor involvement. It's a dowel press. It's not going to hurt them. Then let's take them into a half kneeling landmine press so we can access that entire shoulder girdle in a nice safe scaption plane and get some reaching happening with the shoulder blade. So we're involving more muscles. Then I said, let's take it into the accessory lift section with an 8 kilo weight vest, because the client that they were asking me about had quite a high level of training, but they were being regressed too much for a slight shoulder pain. And I said, look, if they're able to manage their shoulder pain, let's give them an 8 kilo weight vest, because they had access to one. And I said, let's do loaded push-ups with a reach. And if they're able to tolerate it, let's add one chain on the back of it. This push-up with a reach, again, it creates more movement, more motion through the shoulder blade, and that's healthy for the pec minor. Then we can keep the dumbbell front foot elevated split squats, absolutely. I said, let's take it to a half kneeling banded chop so that we're again expressing some rotary movement happening through the spine, and then we've got some shoulder action going on as well. And then the last one, prone handcuffs. Instead of getting them to do 10 reps and having the quality dip off after rep 4 or 5, because when they get tired, it's going to, let's give them 3 reps and just give them a tempo of 2 seconds of a hold in the top position, a 4-second come back around to the backside, a 2-second hold in that bottom position, and then a 4-second come around to the top. They're going to be working for the same amount of time, but at least we're getting higher quality. If they can't manage that tempo, we just cut the exercise. So we're looking through this, this program, and we're seeing the same idea that this exercise physiologist sent me. And like I said to the EP, it's not a bad program. Like this program that they sent me, not a bad program at all, but it doesn't consider this contractility or this flexibility of the pec minor. It doesn't integrate it into any patterns, because all we're doing is just creating more opportunities for it to just be tight and stable and not move, like immovable. So I just suggested maybe changing the way that we thought about the process in terms of, something like a half kneeling landmine press is a great way to reintegrate the entire shoulder girdle as a dynamic stability exercise while the hips remain statically stable. The half kneeling banded chop is the same, but we're just getting the thorax involved as well. So now the thorax is becoming dynamically stable with both shoulder girdles as the hips express static stability. And if somebody has a limitation in hip extension, then you'll find it in an exercise like a banded chop, because when they run out of range through their thorax, it's typically because they've run out of range through their hips. So these are great ways to program, but I built all of these sort of programs, or I still do build these programs, based on the 4 things that I've just gone through that entire recording, which is, do they have enough mobility? Well, if I haven't assessed it and no one else has assessed it, then I'm just guessing it. And there's no point in writing a program based on that. So that's why I like to be able to assess. If I can assess and find someone's weakest link, then I can program around that weakest link and take that link away. And now they're able to express a bit more strength or a bit more power, a bit more speed. I'm improving their performance while I program for these aspects of dynamic and static stability. I'm improving the tissue quality by improving the flexibility. And I can superset a corrective like I have here with this behind the neck dowel press. That in itself is a corrective. It's not a strength exercise, but it's preparing the shoulder for this half kneeling landmine press. So we're asking them to improve the quality of the shoulder girdle's ability to navigate range. And then I'm saying, hey, let's load it. Now let's load it. Let's load that extra range. We don't have to load it so that you can't move the weight, but load it enough so you're getting some really good feedback through the shoulder girdle, because those tissues now have to be doing a job. They can't not, because muscles are just slaves to joints. Insertion and origin of a muscle dictates that if a joint moves, then that muscle has to get involved. So it's very, very simple to understand that little principle there will mean that you can improve the quality of a tissue based on just moving the joint. And then we can go through, like they wanted to keep their heavy legs days, but because of that shoulder pain, they couldn't get into a barbell back squat. So they were doing heavy goblet squats. So that's fine. I love it. We can even improve their ability to get into this back squat position by exposing them to the behind the neck dowel press. And if they use their breath as a limitation or as a way to navigate that restriction, they're going to get better faster by finding that range. If they can only get to here before it hurts, then let's breathe here. let's just breathe here. And then, oh, it's starting to feel good. Well, we can get a little more, and we can get a little more. And it might take 3 or 4 weeks, and before you know it, they've got that dowel sitting on their back. And then we say, hey, we've done 3 or 4 weeks of heavy goblet squats a box. Let's chuck a bar on your back and see how you go. But it's better than just chucking the bar on your back and going, it should be right, because that's not how we get better. And then the other thing as well, like the prone handcuffs. Now I'm just setting a constraint, which is motor control. Show me high quality. I don't want you to do 3 sets of 10. That's 30 reps. If you can do 30 great reps after you've done a whole bunch of rows, then go for it. So if we're here, if you can do 30 reps after you've done, 30 reps of these bad boys, plus you've been holding a heavy dumbbell in your hands for these goblet squats, be my guest. If you can show me that, that's awesome. But if you can show me that, it's probably time to progress that exercise. Whereas here, I'm saying, let's change the constraint. Show me high quality. Let's slow it down. If you can get 3, then give me 4. If you can get 4, give me 5. If you can get 5, let me increase the tempo to 4, 4, 4, 4. But at least we're progressing the shoulder in terms of one of the 3 variables or variations for hypertrophy, which is what we're trying to do. We're trying to improve the tissue quality or the hypertrophy of that shoulder, which is just time under tension. Now, Joey's back. Joey, you had a question for me? And then I'll finish with the recap.
Yeah, man. What's up?
So,
yeah, all right. So, basically, I think me and Michelle were talking down today. Brett Contreras did that similar to that successive induction with when he was doing bench press. Like, just watching the video he did once.
Yep.
Basically, he'd come up here, squeeze everything, then just create as much tension as he can on the way down.
Mm-hmm.
I always thought that was just a stretch shortening cycle because you can get more bounce out the bottom. And then similar to a squat, like you start squat position, squeeze everything, passes on, and then you try and create that tension on the way down.
Mm-hmm.
Is that similar to what that, like, is that similar in terms of like stretch shortening?
It's similar, but remember the stretch shorten happens fast. So stretch shorten is elastic energy.
I know, like with like pliers as well, yeah.
Yeah, you're not creating elastic energy with successive induction. You're creating intracapsular tension. So you're creating irradiation. It's the irradiating effect. So you're creating more global tension as opposed to the short, sharp stretch shorten reflex, which is happening quick. But this is one of the things that I'm most proud of is even though my squat is abysmal, I'm very good at squatting when the weight sits between like 75 and 110 kilos because I'm able to pull myself down. And then just as I get to the bottom, that's where I bounce. And I'm not letting the tension go. I'm pulling faster. So it's a slow pull, slow pull, slow pull, slow pull, slow pull, slow pull, quick push. I can do a video. Oh, I can't do a video. I don't even have a barbell. But I'll find some videos of me squatting if I can. There's not many because I'm not very good at it with my ankles. But at submaximal weights, I'm able to express that really strong eccentric contraction on the way down, which creates a lot of global intracapsular tension. That's successive induction. Then there's the added little bounce, which is stretch shorten, but that only works if you can maintain the tension, because if you let all the tension go, then what are you pulling against to create the stretch? There's nothing there. You're just bouncing off a joint or off a ligament.
Or you might get stuck at the bottom.
Or you'll get stuck at the bottom because you've got no tension.
Yeah.
And that's why most people bottom out on a squat is because they drop in. So if you drop into hip flexion, right, and then you catch yourself at end range hip flexion, your glutes haven't had a chance to lengthen. So now your glutes are catching you at the bottom. And because they've caught you, they're on, but now they've got to contract to push you back up. So they've gone from doing nothing all the way down to isometrically stabilizing the lift. And now they've got to go from an isometric catch to a concentric drive. That's a lot of load. And so based on what we talked about last week, path of least resistance, the brain's going to look for length. It's going to say, well, what can I access that's long because I can generate a lot of force from that? Oh, adductors. And then you'll see knee valgus. Now, I'm not saying it's bad, but I am saying that it's not efficient. It's more efficient to use your glutes and your quads to drive back into hip extension based on successive induction. But if all you're doing is bouncing out of the bottom and just letting the brain find the path of least resistance, that's not necessarily going to be the path of most efficiency.
Yeah, that makes so much sense. So much
Hell
sense
yeah.
to me now.
Hell yeah. Now let's go do a quick recap, and then if Alex has a cheeky cue or Shell has a cheeky cue, is Angus still in here? Angus must have bailed. That's all right. I still like him. All right. So we'll go over this recap. Mobility, the range of motion a joint needs in order to perform the function of that joint. And remember that function is task specific. Stability, an opportunity to demonstrate one's ability to resist or navigate force in one or multiple planes. So if we want a part to move within a pattern, that part is demonstrating dynamic stability if it can show us movement in one plane while resisting or managing the force from the other two planes. So if we go to our squat, think of Steffi Cohen, right? She's not flexing her hip in the sagittal plane because she's accessing external rotation and abduction. So it's not a two-dimensional movement. She's not resisting force in the rotary or the frontal plane. She's managing that force, and she's doing it very well. She's creating full 360 degrees of intracapsular tension, and then the muscle pushes her back up. So she's using her quads, she's using her glutes, she's using her adductors, she's using her hamstrings, she's using her obturators, she's using her gemelli, she's using all of those muscles to generate force on the way down and force on the way up. So when someone says to me, squatting is quad dominant, I say to them, wrong. Absolutely wrong. Squatting is everything dominant because squatting is a full body lift. Deadlifting is a full body lift. Bench pressing is full body lift. And then we had that example before, dynamic stability, single leg deadlift. So the non-moving leg, the moving leg is the fixed leg. And then we watch the other parts get moved. And we're going to talk about this in the next module. But the moving leg, which is fixed, is moving the rest of the body. We want to see the rest of the body stay within the sagittal plane. That's telling us that the hip that's doing all the moving is expressing really strong dynamic stability. If we laterally tilt or rotate away, well, we've lost our dynamic stability. If we don't want a part to move, that part is demonstrating static stability, only if it can show us that it can resist movement in all three planes while movement is occurring in another part of the body. So the example here was a weightless carry. We take the dumbbell, put it in, or kettlebell overhead, and we walk. If the shoulder can show us that it can resist movement in all three planes while we walk, while we're expressing movement through the gait cycle, that shoulder is expressing static stability. Tick the box. When it stops expressing that, you'll see, because you'll start to lose that static stability. Now we pull it down into a different position. We've got motor control, and this can be defined literally as your control of motion. So a caveat here is that no movement is safe or injury preventing. However, just because we want to train in these higher quality movements doesn't mean that the nervous system won't learn from finding itself in bad positions. So I used to think that if you don't qualify for a specific movement, you shouldn't do it. I've now graduated my thinking to let them do it, set the constraints. So if they can't squat to depth, then don't let them squat to depth, especially if there's pain. But let them squat to a box and teach them how to feel their end range and use the box to do that. So set the box at the height of their end range and say, do you feel that you lose all of that tension, that position when you get to the box? If they say nope, then we've got work to do. We've just got to help build that feel. If they say, yep, say, great, I'm going to take the box away. You've got to show me that you can squat to that depth without the box. And now what you can start to do is either take away the load or add some tempo work, and you can start to create different, changes to the tissue around the hip. If it's safe, if it's not like a structural limitation, you can start making changes to the hip because those tissues will eccentrically lengthen over time. So there's a lot of considerations to make here, but ultimately it's learn to feel your way through the movement. And when you get better at feeling your way through the movement quality will increase. And nobody ever got hurt from being better at moving. Nobody. There'll always be strength coaches out there that say, oh, strength is king, blah, 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 blah. You've got to be strong enough to handle the forces. I argue that if I make you too strong and don't teach you how to handle it away from the bar, I'm giving you a loaded gun, not teaching you how to shoot it. So, everything exists on a continuum. That's why it's called a continuum. And we've got to be very considerate about that. So just because someone does not have the range does not mean they shouldn't learn what it feels like to cheat their way through a movement. And I give people Turkish get-ups all the time with a kettlebell, specifically for this reason, because it beats them up. And when you get good at a Turkish get-up, it doesn't beat you up anymore. And you go, wow, this feels so much easier. That's great. That's because you're not cheating anymore. It's because you've built work capacity around high quality function, high quality movement. And then the last one here, we've got flexibility, the length or contractility of a muscle or connective tissue as it pertains to a joint or a joint's active and passive mobility. The better quality of tissue, the better quality of contraction. The better quality of contraction, the better quality of force output or force absorption. Period. That's a principle. That's a principle of physiology. Tissues that are too tight and too short, they can't contract. So if you think about pec minor, it gets too short and too tight, it's lost its ability to contract because it's contracted already. Just because something's long doesn't mean that it's weak. Doesn't mean that it's tight. Doesn't mean that blah, 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 blah. It's just, it's long. And it's lost its ability to contract because it's in a lengthened state. And it's lost that length-tension relationship that it depends so highly upon. So we've got an agonist that might be a little short, lost its ability to contract because it's contracted. And then we've lost our ability to contract the antagonist, let's say the hamstrings here, because they're lengthened based on joint structure. So tissues that are too tight, tissues they can't contract. If a tissue is too long or a tissue is too tight or adhered, then it loses its ability to generate force or absorb force. As a coach, because we're all coaches in here, but there are clinicians in this group as well, and anyone that watches this video in the future, coaches and clinicians can actually make serious gains just by being able to identify a mobility or flexibility restriction. So a mobility restriction could be a tissue or a joint restriction. If you teach someone how to manage that by feel and they take it away, you've automatically improved their performance if they can navigate the new range that they're being given. So when someone comes to me and says, my hip always gets stuck, I don't want them to just rely on me to unstick their hip. I need to teach them how to do it. And when I can teach them how to objectively unstick their hip with a tool, and then they can perform a pattern that says, yep, my hip feels good. We build motor control around that. Then they go and perform a loaded movement. I've just improved that person's function and performance by empowering them to take control of their own mobility, flexibility, and motor control. That's going to improve their dynamic stability through a pattern, or their static stability if they're trying to resist force. Getting good at this concept or this philosophy as a low-level coach or clinician, game-changing, because you can make such incredible gains in such a short amount of time just by taking advantage of these principles. Really, really easy to do. So all you got to do is just spend time developing these concepts in your head and exploring these ranges and explore them with constraints that respect motor control and respect dynamic and static stability. Challenge your own ability to feel your way through a movement. And when you learn to build that movement library in yourself, and then we talk about coaching and cueing later on in the mentorship, you will start to see that changing behavior, performance output, changing behavior is something as simple as just identifying a mobility or flexibility or motor control problem, applying an intervention, building it from the ground up again, and then letting them go and train. And then you'll find you don't have to do anything. You don't even have to, you just talk to them and say hi, give them a program. They learn what they need to do as they go because you're empowering them and their nervous system to learn as they go, rather than just sitting there and spitting cues at them and they're not hearing it. And their nervous system's not hearing it because it's blocked by a mobility restriction or their tissues are too tight or they're always in pain. So these are things to consider. Did any of you guys have any other questions? Cool. Shell, did you just put your hand up? Unbelievable. Shocking. Can't take her anyway. Good shit.
I wondered, it was a little bit more about Olympic lifting. I don't really know the right question to ask, just because obviously, think about a clean in the sense of you talking about Steffi Cohen, creating tension and stuff at the start of the squat. When you drop into a full squat clean, obviously you lose that ability to do a lot of that.
Yes.
But is that just lost in the like just being in the sport of Olympic lifting, or how
Yeah.
do you improve that?
You're
Or is it
right.
just-
So there is an element of specificity there where if
Yeah.
you think about the force velocity curve,
Yep.
successive induction works best at maximal load
Mm-hmm.
because you're using as much global tension as you can to shift as much weight as you can. Whereas Olympic lifting can't be done slow because you've got such incredibly fast movements happening through it. But you can still create tension if you learn to generate the feel. And Mitch Rowe is very good at, he's very good at cleaning because he taught himself how to pull himself under a bar with his hips rather than with his arms. So what he's doing is he's actually setting up the foundation of the catch position in midair, rather than getting under the bar and then bringing the bar down. But when he gets the lift wrong, he's created this circumstance for himself now where he gets the lift wrong by even a millimeter, he loses his ability to generate force out of the hole because his clean technique is so dependent on like high levels of motor control. But it's a beautiful clean. So he has to work really hard at the technique. And there's another guy, Chris Ackland, who's in this area as well. He has Iron Tribe weightlifting. He's the same with his clean. When it's on, it's perfect. The bar path is delicious. But if it's off by a minuscule, I watch him do these lifts. I'm like, you've lost all your tension, man. And then he'll wiggle out of the bottom. I'm like, oh, that was brutal. But the heavier the load, the more that successive induction applies. The lighter the load, the greater level of feel you've got to have, or motor control, because you've got to be able to navigate these forces and catch or absorb the force as it comes down. In the next module, when we talk about moving and non-moving parts and the pillar, which I think yourself and Joe will be exposed to, that's where understanding how the pillar works comes into that more rapid sort of dynamic area of weightlifting. Because if you can stack the pillar under a bar as it drops on you, you're going to be able to absorb and then transmit more force into the bar. Whereas with maximal effort, max load, we're just relying more on joint angles and levers. And so we have to rely on more tissue tension, global tissue tension. But it's a good question. But yeah, it's just something worth playing with, man. Like my cleans got better when I learned how to generate more tension off the floor before the weight even lifted off the floor, because I was getting my whole body involved. So there's an element of successive induction there.
For sure.
And the bar is sitting on the floor. But then as you move through those dynamic sort of positions, you know, the movement changes because it's so rapid. Super question though. Love it. Any more for any more?